welcome you all for the next section of my lecture series of the course Embedded System Design. The topic is, today's session is RISC Architecture. So we have two architectures like RISC and CISC. A reduced instruction set computer is a type of microprocessor architecture that utilizes a small, highly optimized set of instructions rather than the highly specialized set of instructions typically found in other architectures. It was defined by IBM in the year of 1970. So the difference between RISC and CISC architecture is the decoding of instruction is very simple in RISC, whereas in CISC it is too complex. RISC doesn't require any external memory for calculators, whereas CISC requires some external memory for calculations. RISC has multiple register sets are present. In here, CISC only a single register is present. So these are the features of RISC characters. These are the characteristics of RISC. One instruction per cycle, register to register operations, few simple addressing modes, few simple instruction formats, hardwired design, fixed instruction format, then mode compile, etc. So the pipelining of RISC is the most instructions are register to register, two phases of execution like instruction fetch, execute, I is instruction fetch and E is execute. Then for load and store, D, that is memory, execute, instruction fetch, register to memory or memory to register operation. And this is the architecture of RISC. And the optimization of pipelining, here we have delayed branch. It does not take effect until after execution of following instruction. So this following instruction is the delay slot and normal and delayed branch, and this is the format of program addressing program of RISC architecture. And instruction set architectures, that is for RISC, is a very important abstraction. It is an interface between hardware and low-level software and standardizes instructions, machine language, bit patterns, etc. Then advantage, it is different implementations of the same architecture. Disadvantage, sometimes prevents using new innovations. So modern instruction set architectures are IA32, PowerPC, MIPS, SPARC, ARM and others. This is the architecture of RISC, that is the block diagram of RISC. Here it consists of blocks like hardwired control unit, data path, instruction cache, data cache, main memory. So here we have two inputs with dual directions like in and out of memory, that is instruction and data, and instruction cache, hardware control unit, data path and data cache, right? So 64, this is the architecture of 64-bit, that is the general format which we have seen in the previous slide. And this is the 64-bit RISC architecture, which consists of blocks like flag registers, ALU, machine cycle recording, then memory address registers and control unit, timing and control unit, accumulator, temperature register, data bus buffer. This is typically our 8085 microprocessor. We have seen all these same control blocks, processing blocks in 8085 processor, like accumulator, ALU, flag registers, then decimal adjust, temperature register, temporary storage registers, then general purpose registers and special purpose registers like 8-bit and 16-bit, right? So the use of delayed branch by using the program, and this is our timer, traditional programs, how to write a program for the RISC architecture. So when we want to delay, we can use this. And the controversy here is quantitative and qualitative. Quantitative, compare program sizes and execution speeds. Qualitative, examine issues of high-level language support and use of VLSI real estate. And the problems here is no pair of RISC and CISC that are directly comparable. No definitive set of test programs. It is difficult to separate hardware effects from compiler effects. and most comparisons done on toy rather than production machines. Most commercial devices are a mixture, right? This is all about our RISC architecture. In the next class section, let us discuss about RISC architecture. Thank you all.